Hey everybody, so today we're going to be learning from Chapter 8, Lesson 7. This is our last lesson in the chapter before the test, so make sure you are reviewing all those lessons in Chapter 8. We are going to be solving one-step inequalities. That's the title for today. And there's also going to be a cryptic word that I'm going to say during this lesson. Make sure you write that cryptic word in the top right corner of your notes. Okay, so when we are solving one-step inequalities, it's the same way we solved one-step equations in Chapter 7. So this is going to look really similar to you. So we are going to solve each inequality, and we are going to graph the solution on a number line. Okay. Now, I'm going to have 4 examples for us to practice with, and so to review, we're going to be solving each inequality, and again, it's going to be a one-step inequality that we're going to be solving, and then we're going to graph the solution on the number line. Yesterday, we practiced writing inequalities and graphing. Okay, so our first example is x plus 3 is greater than or equal to 10. Okay, so I'm going to rewrite that over here. X plus 3 is greater than or equal to 10. Alright, so when I'm solving a one-step inequality, I want to actually ignore this side of the inequality. And I'm just looking at this right here, okay? I'm going to follow the same 3 steps we followed when solving for equations. So step 1, what's happening to our variable? Step 1, identify where our variable is. Our variable is right here, okay? Step 2, identify what's happening to our variable, or what operation is happening to the variable. Well, it looks like the variable is being added by 3. Okay, step 3 is to undo what's happening to the variable by using the inverse operation. And again, we said the inverse is just the opposite. Okay, so I'm going to undo what's happening to the variable by using the inverse. Inverse of addition is subtraction. And to undo this, if it's being added by 3, I'm going to subtract by 3 on both sides, okay? So subtracting by 3. Now, 3 minus 3 is just 0, okay? So I know I'm left with the variable on this side. And then it's greater than or equal to 10 minus 3 is 7. Okay, now I have found my solution to the inequality. Now I'm going to graph it. Okay, so I have a number line here. Remember that I graph inequalities on a number line, and my solution says that x is greater than or equal to 7. Okay, so I need to think, am I going to include 7 in my solution? Is it a solution? Am I going to include it? Is it going to have a closed point or an open point? Well, if I say the answer instead of my variable, if I say the answer is greater than or equal to 7, okay, that helps a little bit. And then if I plug in 7 for x, I'll say 7 is greater than or equal to 7. And yeah, that's true, right? 7 is equal to 7. So I'm going to have a closed point. Okay, 7 is included in my solution, so I'm going to have a closed point. Now, x, or the answer, is greater than or equal to 7. So I know that it's equal to 7, which is why I have a closed dot, but I also know that it's greater than 7. So I'm going to shade in all of the answers that are greater than 7. Okay, so I just draw a bold shaded in arrow that's pointing that way, saying all the answers are going to be either 7 or greater than 7. Okay, let's try another one. Our next example is going to be m minus 4, which is less than 12. Okay, I'm going to rewrite that over here. M minus 4 is less than 12. Okay, step 1, identify my variable. My variable is right here. Step 2, identify what operation is happening to my variable. Well, my variable is being subtracted by 4. And step 3, undo what's happening to your variable by using the inverse operation, and we have to do that to both sides of the inequality. Okay, so I'm going to undo the variable being subtracted by 4 by adding 4 on both sides. So I'm using the inverse operation. Okay, so negative 4 plus 4 is just 0. So I'm left with m on this side. And 12 plus 4 is 16. Okay, so then I know that m is less than 16. Okay, so I'm going to graph. Again, I'm drawing a new number line. Okay. Okay, now I'm going to look to see if I need an open circle or an open point or a closed point for 16. Okay, so the answer is less than 16. Alright, so I'm going to plug in 16 for m to see, do I need an open or a closed point? 16 is less than 16. Is it true that 16 is less than 16? Probably not, okay? They're equal, so it can't be less than itself. So I'm going to have an open point. I'm not including this in the solution because 16 is less than 16 is not a solution. So it's not included. So you make an open circle, okay? And then the answer is less than 16. Okay, so I know the answer is less than 16. So all my answers are going to be less than 16. Draw a bold arrow. Okay. Highlight the answers. Okay, these things are the same. What I highlighted in blue, they tell you the same thing. It's just different representations. All right, our next example, 5t is less than 35. Okay, so 5t is less than 35. I'm going to rewrite it over here. And again, I'm using the same 3 steps we used in chapter 7. Identify my variable right here. Find out what's happening to my variable. So my variable is being multiplied by 5. Remember, when a number and a letter are close together like this, with no operation in between, it means multiply. So this is 5 times t. So t is being multiplied by 5. I'm going to undo that by dividing by 5. And I'm going to do that on both sides. (35 divided by 5 is 7. So my solution is t is less than 7. I'm going to graph that over here. Okay, and I'm going to see, do I need to include 7 in when I'm graphing? Do I need an open or a closed circle? Okay, so I'm going to plug 7 in for my variable. Is 7 less than 7? No, 7 cannot be less than itself. So I'm going to have an open circle. Okay, and then I'm going to, instead of saying t is less than 7, I'm going to say the answer is less than 7. So since the answer is less than 7, I'm shading in everything below 7. Okay? And the very last example, r over 4 is greater than or equal to 2. R over 4 greater than or equal to 2. Get my number line ready. Okay, so here, here's my variable. My variable is being divided by 4. Remember, this line means divide. It's being divided by 4. To undo what's happening to my variable, I'm going to multiply both sides by 4. I'm using inverse operations. Okay, so 4 divided by 4 is just 1. Okay, so I can just write r, because 1 times r is the same as r, and r is greater than or equal to 8. Okay, so on my number line, I'm going to see, do I need to include 8 into my solution or not? So I'm going to plug in 8 for r. Is 8 greater than or equal to 8? Yes, it is a true. It makes the solution true because 8 is equal to 8. Okay, so we can include it. I'm going to have a closed dot, a closed point. Okay, now the answer is greater than or equal to 8. So I know that my answer is greater than 8. So I'm going to shade in everything that's greater than 8. Okay, once again, I am shading this in. So just remember, everything I shaded in blue represents the same thing. They're just different representations. Last thing I'm going to shade in, because it's very, very important, it shows us properties of equality. I'm going to shade in that I'm doing the same thing to both sides of my inequality. That is really important, and you guys need to make sure you're doing that. Okay, divided by 5 on both sides, multiplied by 4 on both sides. You need to make sure you are doing the same thing to both sides of the inequality, okay, using properties of equality. You need to make sure that you're finding the solution and graphing it, and making sure that if it is included in the solution, that you're shading in your point, because it is a closed point, it's included. If it's not included in the solution, you have an open point. Okay? Let me know if you have any questions in class.